Now what we're working to is we want to work to solving equations that have a log in there. So whether it be ln, natural log, or log here, logarithmic, we want to solve them. So a couple properties that we can see. If, first property is if I have log base b of b, so if I had log base 5 of 5 to the third power, this would just equal 3. This whole thing, this whole side is just 3. That's what it's saying. If I have log base b of 1, if 1's here, doesn't matter what it is, this will equal 0. And then if I have log base b of b, if the base and the top are the same, it's going to equal 1 every time. The other properties that we're going to see predominantly throughout the rest of it is if I add 2 logs and the bases are the same, then I can write them as a single log with multiplication. If I subtract them, I'm going to divide those 2 numbers. If I have a base, if I have an exponent, I can put it out in front, and you're going to see me do this as we go through it. And then the change of basis is what we're going to use to solve. So we go to the first one. Anytime I go through and I subtract, we can write it as a single log, log base 3. So I have log base 3, log base 3. Those are the same. Now we can write them as a single log. Since it's subtraction, we just divide those 2 numbers that come after it. So 27 divided by 81 is, and now we can simplify. This is actually log base 3 of 1/3. Now, this is where you can use your calculator. Anytime I have log base of any log base 3 of a number, if these are both numbers, we can write it like this: log of 1/3 divided by log of 3. If I do that, I want to show you on the calculator. I'm just using Google Calculator. But if I write it, the only thing you need to do is, so you see the log button right here, so I go log, and we said 1/3, or 1 divided by 3, end of parentheses, divided by, and we have log of 3. And if I do that, I get it -1. So what this is saying, let me go back to it. So we did on our calculator, is this whole thing simplifies down to -1. Or you could say this whole thing equals -1. So this is how we'd want to write it. That's -1. Now, when we go to add things, so log base 5, now that's 625. So I'm just multiplying 125 times 625 over 1. So I multiply straight across. 1 times 625 is 625. 25 times 1 is 25. So 625 divided by 25 is 25. Now, does this simplify? We can simplify. We can check it. Again, you could do it 2 ways if you think about it. So you could write it this way on your calculator. Log 25 over log 5 and see what you get. Or you could think about it this way. We want to know, what does this equal? So 5 to what power equals 25? This one's easy. I can do that. Hey, x is 2. So this equals 2. Or again, on your calculator, it's called the change of base formula. We just go through right here and we would go log 25 divided by log 5. And we would get 2. So it doesn't matter either way. I just want to show that log to you as we go through. Some of these where it says simplify if you can. If I can't get a whole number, then it's not going to be simplified. If we go to this one, okay, what it's saying is if I have an exponent, okay, I can rewrite this as in front. So I could say, hey, that's 3 times log base 4 of 64. Well, anytime I have log base 4 of a number, remember I can use the change of base. Log base 64 over log 4. We're still going to multiply. Well, this right here, log 64 over log 4 is equal to 3. So that's 3 times 3, which equals 9. Here, when we're natural log, that's okay. So we're just going to work with natural log. 18, I'm subtracting. When I subtract, then I divide these 2 numbers. So 18 divided by 2, which is 9. Now, I'm not I can actually get a number for that, but we're just going to leave it in that form. When we go to a couple more complex ones as far as combining things. So we go to these two, so we'll have these. So anytime I come through here, so log base 3, so if I have a number out in front, that's going to become an exponent. So that's log base 3 of 7 to the 3rd power. Anytime I see divided by a number, write that as a fraction in front. That's divided by 3, or you could say times 1/3 log base 3 of 6. Now once again, that's number out in front, so that's going to come up and be an exponent. So that would be log base 3 of 6 to the 1/3 power. 7 to the 3rd power, 7 to the 3rd power is 343. So this is log base 3, 343. Now when I add, I just multiply it. Now, the other thing I can do is 6 to the 1/3 power would be 6 to the 1st power, root of 3. Now, when I add, then I just multiply. So I'm multiplying 6 to the 1/3 times 343. I can't multiply those together, still log base 3. So that would be my answer. I simplified it to a single log. Again, when I come through here, anytime I see division, I'm going to write it as a fraction in front. So that would be 1/2 natural log 2 plus 1/2 natural log of 5 plus 1/2 natural log of 3. So if I look at it, these are all going to be exponents. So that would be natural log. So that's going to go up from top, exponent, exponent. So those are all going to be. So it's going to be natural log of 1/2 or 2 to the 1/2 power, plus the natural log of 5 to the 1/2 power, plus the natural log of 3 to the 1/2 power. Now, these are all telling me to multiply. Multiply, multiply, because we're adding. If it's a 1/2 power, that's 2 to the 1st power, root 2. So I can write natural log plus the natural log of 5 to the 1st power, square root of 2, plus natural log of 3 to the 1st power, root of 2. And then lastly, because they're all root 2, I can actually multiply them together, because that's what it tells me. Addition tells me to multiply in log form. So 2 times 5 is 10. 10 times 3 is 30. So it would be the natural log of the square root of 30. Coming through and simplifying these last couple ones, that would be 10 to the 3rd power. This would be 3. Those would be my exponents. I'd say it's log base 9 of 10 to the 3rd power minus log base 9 of 11 to the 3rd power. So 11 to the 3rd power is 1331. So 10 to the 3rd power would just be log base 9 of 1,000 minus log base 9 of 1,331. When I subtract, it just tells me to divide these two numbers. The number on the left goes on top. So it would be just log base 9 of 1,000 over 1,331. Last one, this is actually is pretty simple, even though it has variables. Variables actually make it easier. So that would be an exponent. So that's the only thing I would change there. Log base 5 of x plus log base 5 of w squared minus log base 5 of z. Anytime it tells me to add, then I multiply the two numbers. So that would be log base 5 of x times w squared minus log base 5 of z. And then when I subtract, then I divide. Number on the left goes on top. So it would be log base 5 of x times w squared, log base 5, over z. And that's how I write it. So just remember your properties. When you multiply, or excuse me, when you add logs together, you multiply those two numbers that come after the base. When you subtract, then you're going to go ahead and divide those numbers. If I have a number in front, then it will be an exponent.